Hi everyone. I solve problems on Leetcode. Here I solve it in leaf, so it doesn't have high quality. I watch was I solve it or not. I completed the top of this roadmap, and I continue with trees, and I'm going to solve more problems on trees topic, because it is the base for almost all of other topics, as you see on the roadmap. So invert binary tree, I didn't solve it earlier. Let's try to solve it. What the topics here? Depth first search, breadth first search, and binary tree. Let's watch what does it mean, invert binary tree. So we have the link on the root of binary tree, and we need to return invert it and return its root. Inversion means we need to swap right and left subtrees for each node. What I'm going to do, I need to first approach, which is going in my mind, is to use recursion and invoke it for each of the nodes. Let's do it. Probably I could use something else. For example, Q, but I think for this task, this question is okay. It is okay to use inversion, at least as first approach. So I need some helper method. Let's say it's swap function node var current node left. Then we keep the link on the one of the sites in the current variable. Then we replace left with node right, and right on the, when we put the previously stored link on the left subtree to the current. First swap methods is done. We can use it. What can we do? Then after it, we need to traverse our tree and invoke this swap method for each of the nodes in the tree. So let's write it something like that. Traverse route swap. And return route, because route will not be changed. Let's write the traversing method, which will how to say it, which accepts callback as an argument. So root callback, sorry, function extra space. So how can we traverse it? Let's traverse. So we can use both of the traverses, or depth first or breadth first. I think breadth first is one of which I come first in my head. So let's do it. Let's implement this one. What I need to do is I need to do callback route. Then I need to traverse route left and traverse route right, and I need, if not route, I need to exit from recursion if we reach node. Here should be node. If we reach to the end of the tree, and that's it, I think. Let's try to run it. Callback node. What is the problem? Callback is not a function. Sorry, I forgot to pass it. Yeah, it works. Let's try to submit it and watch what we got. Oh, it works, it passed, but we have awful runtime and memory usage. Why is like that? 59 milliseconds and 49 megabytes. I don't have other submissions. First of all, let's try other approach. How can we improve our performance? We could traverse without recursion So we and this is how we remove the memory, extra memory usage, and we can reduce memory. But how can we reduce how can I reduce the performance, improve performance time? I have no ideas. Probably I can I can write all of it inside of one of the function without creating extra functions. But I don't think probably it's a good idea. Let's try to move swap inside of, let's try to move all of it inside of our main function. Then let's move it outside, so we will not create variable inside of swap method each time, and we just use it like this. It should increase some memory, probably. Also, we can, we can don't pass it as callback, but I don't know is it actually good idea or not. Let's watch, let's try. Runtime 53 seconds. Already better. What can we do? Again we can remove our swap method and do it inside traverse. Let's try to run it again. Yeah, it is better, much more better runtime. Let's submit it. But when I submit it, it doesn't improved a lot. It's better, but not a lot. Even 49 milliseconds would be somewhere here. But 49 milliseconds would be much better result. It is 49 because it runs not on the whole set of cases. Okay, let's try to implement it without recursion. Without recursion, how can we traverse the tree? We can traverse it with using queue, but it is probably queue, it is not. I don't know, let's just try it. So with queue we put Yes, we put while ku length, we put nodes to the tree, and we remove it from tree each time when we make swap items here. Var ku consist root. First of all, what we should do, what is our constraints? Could be is empty. Yeah, but we will resolve it later. Aha, if root, no, if not root, we start with unshift current, unshift current node, I mean current unshift q unshift. It is the current node. Let's say it node. Sorry. And then what we do, if node q push node left, q push node right, also we swap current with node left, node left, node right, and node right is current. So if we have node, we do all of this. And that's it. If we don't have node, we do nothing. After all of it, we return node. Let's try to run it. Bad sign, time limit exceeded. How can we resolve it? We can check if we can put items inside of our queue only if the items is not empty, and we can remove this check. But we need to check it here if not root. So item inside of item, first item couldn't be empty and other items couldn't be empty. Let's try it like this way. In this way doesn't work. What unshift do? Probably I understand unshift to the beginning of an array. But I need to shift, not unshift. First element. I need to use shift. Sorry. It works wrong. Why? Probably I need to put items to inside of the queue before I swap its positions. Let's try it. No. What's wrong with it? So we have queue, we have item inside of the queue. If we have it, we push it inside of our queue. We remove a current item. So we should process all of the items, but something goes wrong. Let's try to just simply console log node value. Four two 7 1 3 6 9. I traverse items. I correctly traverse them, but my code do something, make something not correct. So we have node. I didn't declare variable node. And it's still wrong answer. So we take first item, if it has left subtree, we put it in, push it to our queue. To the end of the queue, yes, that's right. Left subtree, right subtree, then we on the next iteration we take left subtree, make everything with the left subtree, put its subtrees to the end, and on the next step we will, I don't know what's wrong. Current. Aha. The Mr. Yes. Bug was in the variable names. Let's try to submit this one. It should be more performant. Yeah, but not a lot. Actually, I don't know how to improve it more. We improved memory usage, but didn't improve runtime. I'd like to watch solutions. So currently, to how to say, bottom line, I solved the question. I solved the problem in two ways: using recursion, using using queue, without recursion. Also, I could solve it using stack, but I forgot it, and I decided to don't use it. Now I'm going to watch solutions and learn which methods we can use. What I'm missing. But probably I'm not missing anything, but I just in this case I just watch solutions to be sure. So recursive and iterative approach. Do you have, yeah, JavaScript solution? Let's watch it. Runtime 64 seconds was faster than 92% of users. Wow. If root null, return null. Invert tree on the root left, invert on the root right. Swap them, then return root. So this is recursion. Where is the iterative approach? Recursive, iterative. So linked list. This is the queue method. While queue is not empty, take first item. If yes, it's similar, then swap items. Okay, breadth first search, code, invert tree. It is the same with not. He has inner loop for what? While queue length. and while he has items inside queue, queue shift. I'm not sure it is correct to work with queue to iterate through some structure with for loop. So you have fixed you don't have fixed iterations. So you think you have fixed iterations amount, but your queue no, you have fixed iterations amount because you stored queue length, initial queue length, to a variable. So you do it, but you changing queue while you moving through queue, while you iterating it. You pushing here to inside of the queue. So yeah, it's just an extra loop which you don't need. Also, this extra loop can cause bugs. Let's skip it. How you solve invert binary tree, recursive approach, etc. If the root is null, method to swap nodes, swap root. Your swap method doesn't make only swap, it is also recursively call traverse through the tree, but it is nothing new for me. Invert tree. It is interesting. Recursion DFS. Using stack. And using breadth first search with queue. And right and left. What is this? I don't understand. Let's start with this one. So we put a root into the queue. While we have queue length, we take the current node. If it's not null, we swap them. Then interesting. You creating this array, then you write the right link to the right subtree inside of the left link and the left to the right. Interesting. It is something. It's hack, I think. Here is the same, but only using stack. Let's let's try this one. I'm interested. How can it work? How much performance it shows. Not a great performance, at least on simple run, but while submitting it shows great performance. Not great memory, but great runtime. Why? I don't understand why. Because of only one comparison inside of the loop, probably. Don't know. Let's try to sorry, I would like to use it in my solution. Sorry. Note. Let's run it. Huge runtime, but if we submit it, yeah, bad runtime. Also much worse memory. So what is the reason? The core is in what? He don't have these two comparisons. How to say, checks, ifs. All of other is the same. Not here, but here if continue. Q, I don't need current, so we compared it. Q push node left, node right. We push it anyway in any case. Then we swap them. Try to run it. What's wrong with my probably the naming is hack, is one of the hacks. I'm interested why it beats yeah. So if you declare your method like this, it works worse than if you declare it like this. Because I changed only this, and it increased from something like 20 something to 63%. Okay, guys, I think that's it for today. Thanks everyone who watched, and bye.